So on this video, I'm going to go through the practice problems for these different wave equations that you will be solving. So let's go ahead and look at this. Just a note here that you should have these following equations added to your equation note card. That the velocity of a wave will be equal to lambda, which is the wavelength, times the frequency of the wave measured in hertz. Similarly, you can solve for lambda if you know velocity and frequency, and you can also solve for frequency if you know the velocity of the wave, the speed versus its wavelength. So again, this is your first equation, and the other two can be derived from it, and we should have those all added to our note card because we'll be using these to solve the different problems. So problem number says a tuning fork has a frequency of 256 hertz and a wavelength of 132 meters. What would be the velocity of the wave? So first off, of course, we have to have our equation. So velocity would be equal to lambda, wavelength, times frequency. So the wavelength again was 1.32 meters, and the frequency was 256 hertz. Now remember that hertz actually equals the number of waves that come in 1 second of time. So in this equation, I'm actually going to change this to 256 waves per second. Okay, now waves are a thing, they're not a unit, so we've got our units are going to come out in meters per second, which is a measure of velocity. And now we just need to do the math. So when I take 1.32 times 256, I get 337.92 meters per second, which is a measure of velocity, distance over time. So you just got to remember that hertz is actually number of waves in 1 second. Here in problem number 2, it says a certain wave has a wavelength of 1.2 meters and a velocity of 0.75 meters per second. What would be its frequency? So from my equation note card, I know that frequency is equal to the velocity times the wavelength, which is the symbol lambda. So from our information here, we know that the velocity is 0.75 meters per second. We're going to divide that by the wavelength, which is 1.2 meters. So now we'll see that meters will actually cancel each other out. Numerically, 0.75 divided by 1.2 would be 0.625, and that would be number of waves per second, or we can say that it's 0.625 hertz. Because remember, a hertz, which is a measure of frequency, is equal to the number of waves in a second of time. So frequency, and this is of course equal to the frequency.